Good morning, everyone, and thank you so much for joining us for today's session. We are celebrating women in engineering, and today's sessions are going to offer you a great learning opportunity for you to understand about different careers in engineering, sustainability, and STEM, and highlight the amazing women, three of which we have today in the engineering sector. So we've called today's session Eco-Conscious Engineering and You. In this session, you're going to gain some insight into careers in engineering which help protect and restore our planet. And you're going to meet some inspiring role models who have careers who all contribute to protecting and preserving our planet. Today, we're going to be hearing from Heather, Rachel, and Divya about their career journeys and their amazing work in engineering and sustainability. My name is Rachel. I'm from Founders for Schools, and we're going to be hosting this session today. And we hope that you will gain some insights into careers in engineering. To the audience at home, please do listen and think about any questions that you have. Please do pop any questions into the chat box, and we can ask our speakers as we go along. Any of the questions not answered, we will pass them on to our speakers and get them answered for you. We are recording the session today, and it's going to be on our YouTube channel and our F4S platform. So sit back and enjoy the presentations and make some notes and think about some of the questions that you have for our speakers today. So thank you all very much. Thank you, speakers, for joining us and agreeing to share your stories today. I'm going to pass first to Rachel. Rachel is a chartered environmentalist with 40 years experience. Making sure sustainability is at the heart of business decisions is one of her most important priorities. Rachel has worked as an environmental manager on major transport and city centre projects, designing and building modern and sustainable developments. Rachel is also a trustee with London Wildlife Trust and the Southwood Foundation. Thank you very much, Rachel, for joining us. We'd love to hear more about what all of that means for our students at home.
Okay, lovely. Thank you for that lovely introduction, Rachel. I'm pleased to be able to speak to you today. It's all about sustainability, isn't it? It's the career to get into now. We're in this climate emergency. So I'm sure you'll be thinking, how on earth can I be contributing to this global emergency that we have? So I've got the little model up there for you. And sustainability, what do we mean by sustainability? It's that sweet spot in the center of that diagram where we are doing things that make business sense, are good for the people as well as the environment. So your role in, if you were to take an environmental manager's role, something similar to what I've been working in, you'd be concentrating on that green spot there and making sure that we do everything for the environment, but respecting the society and the economy as well. In the past, we've probably been concentrating too much on the blue spot, so we need to reorientate ourselves to really that green area. Okay, the next slide, please. So as an environment manager, yes, we've got laws that we need to make sure that we're complying with, business needs to comply with, and we have lots of stakeholders that are in that space. So the people like Environment Agency, Natural England, local authorities, planning authorities, county councils, loads of people working in that area, but your job will be to find those opportunities where we can be greener and better and change the way that we're doing things. Yes, we actually need to change the way we're doing things to actually make us not a throwaway society, but to actually use materials to their best advantage. Okay, next slide, please. So as my role as an environment manager on High Speed 1 railway, we had to design the railway through the Garden of England in Kent to be a sustainable railway. And you can see there that we mirrored very often the motorway corridor so that we minimised impacts on people and on resources. And that is a bridge over the River Medway. You can see the beautiful, sleek design of that railway bridge, because the noise barrier to protect the people from the noise from that train is integral to the design of that bridge, innovative bridge design. So you could be innovating the next high-speed noise barrier, something as innovative as that, or as something to do with the countryside. So completely massive different things that we can be doing to protect the environment. So next slide, please. And massive construction project, and you can see the construction there on the left hand side, but on the right hand side, as we left it, we protected that ancient woodland by building a tunnel beneath that, and our construction methods allowed us to do that. Okay, next slide, please. And so you can see that actually environment means a lot of different things. We can think about ecology, landscape, and increasingly we're talking about energy, carbon, how much carbon is embedded in our projects, solar panels, trying to use renewables wherever we can, and clearly minimise any waste that is created and reuse those materials. So there's lots and lots of ways where you can get involved in the environment. So now, actually, there are over 600 jobs, 600 courses in English universities featuring environment. When I started out, there was very, very few. So think about the area that you might be interested in. It is a industry now which is massively under-resourced. So could I have the next slide, please? So we have the sustainability job market is booming. There has never been a better time to pursue a career in sustainability, and that was from Duke University from only this month. So there's lots of ways that you can get involved. We have a climate emergency. We have to minimise the amount of emissions that we're creating to keep our planet safe. So there's lots of great opportunities. I impress you to get out there and have a look for yourself. Thank you very much.
Thank you, Rachel. I'm wondering, how are young people, so we have young people at secondary school and some primary schools listening, what kind of things could they be doing now to position themselves to kind of get into sustainability, do you think?
Excellent idea. Excellent question, Rachel. You can be going out there, maybe volunteering. There's lots of charities. For example, I'm a trustee with London Wildlife Trust. They have family events where you can go along and learn about what are in these sites, what we could be doing. Go and be part of, if you're a guide or a brownie or a cub or a scout, get out there in the environment, be experiencing it. I grew up, and you because you go out there, you enjoy it, therefore you can be realizing that that's what you want to do. And there's lots of places that you can volunteer and maybe try and get some work experience. Pick up the phone saying, I want to come, and people like me, be lovely to have somebody of that age come and see somebody working in that environment, in that space.
Yeah, I like that comment. Asking for help is really key, and just asking for help and saying yes to opportunities that come along. And don't be afraid to do that as well.
It's very hard for somebody who's got a career and knows that they were in that place at one point in time, and if somebody emails or rings up and says, can I come and have a day with you, I'm sure most people would try and facilitate that. So
do you think, Rachel, that to get into sustainability that you have to study certain subjects at school, or can it be from a range of subjects? So some of our students might be thinking about their GCSE options at this point.
I was lucky that I did my course, and I needed A science and I had biology, so that enabled me to do my course. So I do if you can have a STEM subject, I think it is helpful. Nowadays there are, as I say, over 600 university courses with environment, so there will be some arts and some science, but if you can have a mixture of arts and sciences, certainly some sciences, that would be helpful.
Brilliant, thank you, Rachel. So we're going to move on to our next speaker today. We've got Heather. Heather is a trainee geophysicist at Fugro. I think I've said that right. She uses maths, physics and chemistry to image the geology under the sea and under our feet. And she uses physics to model earth processes such as weather, earthquakes, sedimentary processes, glaciation and climate change. And Heather says that the language of nature is maths. So understanding that allows us to do better. Heather, I will hand over to you.
Thanks very much. I'll just share my screen, see if this works. Okay, so as Richard says, my name is Heather. Today I want to talk to you about what geophysics is, what geophysics does, how we acquire data, and most importantly, why geophysics is a key part to green energy engineering. As Rachel said previously, now is the time where we have a climate emergency, and it's more important than ever to understand not only how our planet works, but how we're going to save it. So what is geophysics? Geophysics is the mathematical and physical study of our planet. It covers everything from climate and weather to rivers and oceans, how it interacts with our atmosphere, how our planet interacts with space in our solar system, and of course volcanoes and earthquakes. So what does a geophysicist do? The best way I can illustrate this is with a picture. Most people think I go out and collect rocks, and to be honest, it's not far from the truth. But what I honestly have is the best job in the world. I get to work offshore in the North Sea, and I get to do cutting edge science, which I think is great given our climate emergency. Maths is the language of nature. To understand nature, you have to understand how to translate it. Just as you understand English or Spanish or French, maths is the language of nature. It allows us to translate the physical processes happening around us. So for example, if you see ripples on water, the exact same physical process is happening in seismic waves that are propagating through the earth during an earthquake. Or if you look at an atomic structure of an atom, we have electrons orbiting a nucleus. That's very similar to how the planets orbit our sun and our solar system. So literally from the atomic scale to the mega scale of planets and galaxies, circles and ellipses are everywhere. Another example of geometry in nature is hexagons. If you look at beehives or basalt columns, basalt is a type of volcanic rock which is extremely high temperature and cools very slowly. It forms these hexagonal patterns. Also, when you blow bubbles, you get these kind of patterns. And what scientists have found is the most efficient way to pack atoms is in a hexagonal structure. And this is actually found in the core of the Earth. In the core of the Earth, the metal iron-nickel alloy is aligned in a hexagonal structure because it can help support the stress of the intense pressure. So when you have pressures, temperatures, or tensions, you always get these hexagonal patterns in nature. We also have a lot of waves. If you look at mountain ridges, or maybe heartbeat monitor, or even a magnetic anomaly, they're all very similar. So when you go to high school and you do a bit of sine, cos, and tangent waves, you start to understand these things. Here's a little graphic about how we translate our knowledge of maths and physics and chemistry into how we gather data from the seabed. So I work on a boat such as this one. This is a survey boat. On the bottom of the boat, we have something called a transducer, and essentially this just sends out a pulse of waves down through the water, into the seabed and through the geology, and reflects waves back up so we get a picture. Essentially, it's like taking an X-ray or an MRI scan of the geology. And there's many different ways we can do this. As I said, I work on a boat, but we can get satellite data. There's people who fly planes for aeromagnetic surveys. We also have these tiny little boats here. They're called ROVs. These are remotely operated vehicles, so people can drive these from an office thousands of miles away, and they can remote into these vehicles and they can drive them. I just got a little video here illustrating how our surveying works. So here's the bottom of a boat. This part here is our transducer. These are the waves that it sends down through the water column. It then goes into our seabed through the geology, and then the waves reflect back to give us a picture. And this is the kind of thing as geophysicists that we see. This is real life data of the seabed. Now, as you can see, the seabed is not flat at all. It's not flat. It's exactly like the topography you get on land. There are underwater rivers, underwater canyons, and there are underwater mountains, such as these ones. Here is an underwater canyon. That's literally carved by brine water under the ocean floor. And these things are what engineers want to know, because they want to know where to build things offshore. They don't want to build it in the middle of the canyon, obviously. So here's some real life data we acquired on a survey I was on recently. This little dark mark here is a pock mark. This is gas escaping. It's extremely environmentally damaging, and it's also very dangerous. You do not want to build anything on top of that. You do not want to, for example, put an offshore wind turbine on top of that, because it will explode. We also find things such as scarring. This is caused by icebergs from the last ice age. So these scars are 10,000 years old. You also get deep water corals in the North Sea, believe it or not. These are very different to tropical corals. These are pelagic. And some of them can be, again, up to 10,000 years old or even a kilometre wide. And here's actually a picture we managed to take of this from the seafloor. So this is a real life picture of a section of this coral. And we also see things. This is something called side scan. This is a different type of wave that we use to see different things on the seabed. And if you can see here, there's little ripples here in the seabed. It's very similar to when you go to the beach and the tide goes out. And that's exactly what's happening here. These are caused by tidal flows under the water. Over here, we have a magnetic anomaly. Now, I know it just looks like blobs of color on a page, right? But these are actually highlighting metal parts on the seafloor, and especially bombs. You'd be surprised the amount of bombs that are left over from World War II in the North Sea. It's quite staggering. Again, you don't want to build on top of that. Here's seismic data. This is probably what we use the most. This is a picture of the geology underneath the seabed, and already you can see the structure of the strata in the rocks. You can see how they're bending. You can see how there's an unconformity here. These are the kind of things which enables us to tell engineers not only what kind of rock we have, but if it's suitable enough. Is it going to hold the weight of your offshore construction? Is it going to be able to hold tension? Things like that. So offshore wind farms, the most thing you got to think of is, where do you put them? Because after all, 30% of offshore wind farms are going to be built in earthquake-prone areas. And also a third of your foundation design installation is the total of your project cost. So a third of your project cost goes into where you want to build this. So you really have to get this right. As I said before, the seabed is very dynamic. It's not flat, it moves. You do not want to build offshore wind farms in an area where they're going to be carried away because the sediment is moving. Also, your foundations must be strong. You've got to know what rock you've got and if it's going to be able to support your foundations. You have to think of an adequate cable route as well for getting the electricity on shore. A lot of people forget about this. You might have an offshore wind farm, but how do you get that electricity from the offshore wind farm on shore? You have to have a suitable cable route. You can't put it over mountains, for example, or where their sediment is moving. Is it going to be in shallow or deep water? And is it going to be floating or anchored? Fugro, the company I work for, has been involved in some of the largest offshore wind farm projects in the world, such as the London Array that powers roughly 500,000 homes, as well as Dogger Bank that powers roughly 6 million homes. And currently in Scotland, off the northeast coast of Aberdeen, we're working on the Marram Wind project. Again, that's predicted to be about 3 gigawatts, so again, that will power roughly 6 million homes once completed. here's a graphic of our offshore wind farm survey. So here we have the geophysicists gathering our data. Again, we gather data of the seabed, data of the geology, and then we can refer to engineers where the best places to put the turbines are. And as geophysicists, what we do is offer engineering solutions. For example, I talked about where do you want to put your cable route. Here's an example of where we have some mounds in the seabed. We have some higher topography. You do not want to be putting a cable over topography because your cable is going to be like this. You want to put it along the valleys essentially. So this is where we worked on a project and we basically mapped out the most efficient route for this cable without it snagging or anything, for example. So that's the end of my talk. Thanks very much for listening, everyone. I hope I gave you an insight into what a geophysicist can do. This is a very small portion of what we do. And there's also those of us that work on land, work in nuclear sector, for example. If you have any questions whatsoever about geophysics or STEM in general, my email is up there, so is my LinkedIn. Please get in touch. I'm more than happy to answer any questions. Thank you.
Thank you so much, Heather. That was really interesting. Absolutely fantastic. I think we can see there that there are lots of opportunities for young people to work in that sector, and that there are lots of different jobs. And who knew there was so much going on underneath the sea? You know, it's fantastic. So I'm going to move on to our last guest speaker today, Divya. Divya is joining us all the way from Australia today, which is amazing. Thank you very much, Divya. Divya is a space systems engineer who's designed, built and tested satellites and other technology for space. She works with lots of different people to make things like cameras for space and systems that can detect gravity from space, and also satellite systems. She's worked for a company that make the cameras, which are called imaging sensors, that took photos of Comet 67P, Mars, and also lots of stars. And she's now working on some new technology called quantum sensors. They're going to be used to detect gravity and magnetic fields in space, and could help humans to start living on the moon or Mars. So get packing. Thank you very much, Divya. I'll hand over to you.
Thank you for that lovely introduction. So just give me one moment. Okay, yes, hello. And today I'm going to talk to you a bit more about eco-conscious engineering, but a bit more out of this world, and is a problem which we know as space junk. So I want you to think about what might be floating around up in space around the Earth at the moment. So there's about 2,000 active satellites floating around the Earth. Then on top of that, once the satellites stop working or it's the end of their life, they still stay up there. So then there's about 3,000 dead satellites also floating up around there. And when a satellite reaches the end of its life, there's one of two things that will happen to it. So it will either be pushed into, there's an orbit around the Earth, which is called the graveyard orbit. And that's, they'll push the satellite into that orbit. And there's some satellites, if they're a bit smaller, they'll be pushed closer to the Earth so that they deorbit and they spiral in towards the Earth, and because they're moving so fast around the Earth, they eventually burn through the atmosphere and disintegrate. And then on top of all the kind of larger objects, you've got the satellites. You also have other, what we call them debris, or pieces of, it could be pieces of old satellites or other objects that are up in space, but there's about 128 million pieces that are bigger than a Cheerio. And then even more kind of bigger than that are about 34,000 objects that are bigger than a bagel. So in space, even the objects that might be 1 centimeter or 1 millimeter can be really, really dangerous for other satellites and can damage them. So there's a lot floating around in space, and that's something that engineers and scientists consider a problem that we need to look at. So why is space junk a problem? And there's two reasons really. So as I told you, there's lots of satellites up there, 2,000, and then probably lots more that will be there in the future, which are up there helping us to do really useful things on Earth, communications, providing internet, television. So if those satellites get damaged, then that stops all those services on Earth. And if you look in the top left-hand corner of the screen, that's actually an image of the Hubble Space Telescope. And you can see you can see the damage that's been done to it by some space junk that was floating around. And as I mentioned before, when the satellites are burning through the atmosphere, sometimes if they don't completely burn up, they will fall down to the Earth. So on the bottom left-hand corner, you can see an image of a part of something that's fallen down from space. So you can imagine there's also dangers with life on Earth if something was to fall that was a large, dangerous object. So the cosmic cleanup. So engineers and scientists, we're working on how we can clean up space. So it's really important, obviously, to keep the Earth clean, but also as we're sending more and more satellites and spacecraft to space, the issue of space junk is just increasing. And we need to do more to stop and there are a couple of things that engineers and satellites do. One of the areas is, so first of all, you need to know where these objects are, where this space junk is, if you like. So you need to know where the active satellites are, and you need to know where the space junk is. And so you need sensors to track these objects. And this is a picture here, which you can see all the different ways that engineers and scientists on Earth are looking to find out where all these objects are. So you've got using different types of the EM spectrum, electromagnetic spectrum, to see where objects are. So you can do it by using optical tracking, radar, and this is a full-time job. So then once we can map where all these objects are, that's really useful because then it allows us to see if there is any danger to any active satellites up there. So then the second thing is, so all the active satellites that are being operated, that are all any large objects or even small objects, and we can detect it, then we need to actively, or the satellite operators, they need to actively move their satellite so that they can avoid a collision because it could seriously damage their spacecraft. So the other area of engineering is satellite operations. So you could be the person sitting in front of, in the control room, moving the satellites around, which is really exciting. And the other area that engineers work in is coming up with really creative ideas so that we can move this junk in space, and either we can push it into the graveyard orbit, which is probably not the best thing to do, or bring it closer to the Earth so that it burns up in the atmosphere. And you can see here, there's this big spider type claw, and this is actually a design for a system that is being used to go up into space and, you know, lock onto a satellite that's dead and no longer active, and then move it. So it looks like something from an arcade, you know, where you're trying to win a teddy bear. But some of the ideas that engineers are coming up with are really innovative, and you could be one of those engineers that has to come up with an idea. There's also a really interesting idea where you have a net in space, and the net is used to, you know, capture your satellite. You can work on as an engineer to help clean up space. So that's just a quick snippet on that, but thank you for listening, and I'll be happy to answer any questions.
Thank you, Divya. I think actually it really highlights the importance of not only looking after the planet down here, but also looking up into space and protecting that as well. And it's something that maybe some people listening haven't thought of before, and was really interesting. I think it would be interesting just to do a couple of questions before we finish. I'm conscious that young people just are thinking, right, that sounds amazing. how do I get there? Perhaps, Heather, you can maybe talk about what you studied at school, and what your kind of career path was. What were your thoughts when you were at school as to what you wanted to do when you were older?
So you'll all laugh. I wanted to be an artist when I was about 15. My heart was set on going to art school, but I always had a passion for science. I grew up in Scotland, so I did something slightly different to GCSEs, but I guess I did chemistry and physics, GCSE, and geography. Those are the main sort of three things. Like, I would say do some kind of science, and pair it with geography if you want to do some kind of geoscience as a scientist. As I went into university, I studied geophysics and geology at Edinburgh. Again, as Rachel said previously, there's so many careers out there. It's so various. There's lots and lots of different university courses you can do as well. But I would say, you know, focusing on STEM subjects is a must if you want to be like, you know, like an engineer or a geophysicist. But if you want to, you know, if that's not necessarily for you, for example, you hate maths, I don't blame you. I hated maths for a long time as well. There are other ways to go through it. You know, there's plenty of people that study business and they go into policy making for environmental stuff. So don't feel disheartened if, you know, for example, you're maybe late on in high school and you're thinking, oh God, I've not got a STEM subject. Like, as Rachel said, you know, like a lot of people are looking for careers. It's a huge job market because the climate crisis is so pressing. So if you're passionate about it, I think you will get a job in it.
Yeah, there'll be a way in, hopefully. I wonder if perhaps Divya and maybe Heather, you know of any other routes apart from university, you know, for instance, apprenticeship routes into the careers that you have?
Yeah, Rachel, I didn't do it myself, but I did work with some really amazing apprentices. So at one of the first companies I worked for after I went to university was called Teledyne E2V, and they're based in Chelmsford in Essex. And they had a very good apprenticeship scheme, and I think they still do, so please check them out. And they make the imaging sensors that I mentioned for space imaging, and also for imaging on the ground and for telescopes looking up into space. So they had a very good, or have a very good apprenticeship scheme, and their apprentices get to move around in all sorts of departments within the company. And I think that's also a fantastic way to get in. And I know some of the apprentices have now gone off and, you know, become full-time engineers, and some of them are also doing a degree as part of their apprenticeship. So I think that's also a really interesting route where you get hands-on experience.
Yeah, I'll also just say a quick bit. I'm not so sure about, I'll say apprenticeships, but we do offer a lot of internships within Fugro, like summer internships, things like that. But what I would say, like, work experience is so valuable. It's almost more valuable than a degree to some extent. If you can get any kind of work experience whatsoever, in any kind of engineering, environmental, geology, anything like that, please do it. If you want to go down the engineering route, apprenticeships are fantastic because you get hands-on experience. There's a lot of people who do university courses, which is fantastic, but university at the end of the day is very theoretical. You know, if you want a practical job, apprenticeships are almost, you know, on par with a degree. So I wouldn't completely knock out an apprenticeship.
No, I completely agree, Heather. My course was actually, I did a 4-year course, but a year of that was spent out work experience, and courses like that I think are invaluable. And because mine was a vocational course, I did environmental health at university first, or what was then a polytechnic. You know, it was the stuff that you were doing was academic, but it was also geared to the job. So
fantastic. So it sounds like really there are lots of different ways into engineering and sustainability. And I think, like Rachel was saying earlier, just get yourself involved, look for work experience, volunteer. If you're doing clubs outside of school, you know, get involved in any sort of sustainable projects or activities. That's fantastic. Thank you so much for all of our speakers today. Absolutely, if you have any questions or want some further information from any of our speakers, please do get in contact with us and we can send them on. Just thank you so much for the speakers and everyone for joining us today. You will be emailed out a survey form. We would really appreciate your feedback on our session today and any of our other sessions. Please do look out for the recordings of today's sessions on YouTube. And if you're not already following us, we are on Twitter, Facebook, LinkedIn and Instagram. And please do look out for any of our other online events. We have another coming up this afternoon. Thank you very much to everyone and goodbye.